And we'll start with the city planning solutions. So urban acupuncture, network cities and science, simulative modeling. Yeah, sure. Yes, please, that was you.
Kaija, the camera is there.
Okay, sorry. Thank you.
Hello to everyone. Are you hearing me?
Yes.
Okay, so I will share our presentation. So, my name is Evaldas Ramanauskas, and I'm very happy to participate in this evening. So, I will present our proposed projects for the small towns that challenge with such problems of declining population, as well remoteness from other bigger towns. So, we can mention the fact that these small towns have such situations that any small economical investment or any other housing, it gets very big importance. But if such small, even very small housing will be carried without any data analysis, it not each case it can get best results. So in our opinion, it is very important to determine exact valuables of towns, significant places of urban structure. That is why our idea and our object is to determine urban potential of urban structure. This idea is based on a fact that there is a constant interaction between urban spatial structure and its social, economical, ecological content. This idea will be based on modeling various models of urban structure using mathematical graph systems, as well using rules of space syntax. So the scheme of our methodological approach of the project, here we can see the cycle which combines two types of data. The first type of data will be spatial data, which we can collect from OpenStreetMap, as well as GIS sets. As well, second type of data will be social information, economical activities, as information of inhabitants, as well tourism, cultural information. These data will be combined together and we can get such outcomes like first one could be Atlas of Urban Acupuncture. So all these activities will be fixed on a map. As well, this lets us to analyze data for various proposals as well to add to these maps. And eventually we can get proposals of practical development of urban structure when we get various synergies of urban structure and social information. We can see few examples we have already done. Here is a map of acupunctural points. Here's a map in Kaunas where we get information from inhabitants and we fixed on a map. This information can help us to generate various urban analysis of using mathematical graph. We here see different synergies. Colors shows the red color that's the best synergies are looking at exact urban space and comparing with selected social content. So we can use different these synergies. And eventually we can carry such a proposal map which can show the most significant places, the most valuable places, as well spaces, buildings, which are most important, and that lets us to determine what activity could be carried in exact zone or street or any parcel. As well, this, for example, can help us to determine where we could rise building intensity, height of buildings, as well where we could preserve our open spaces, streetscapes, landscapes, as well surroundings of cultural heritage. So it's, in a short way, it's our proposal. So if I have any time more, I can answer your questions. Thank you very much.
Right, exactly.
Well in time. Any questions?
Yes, Evaldas, do you already have a couple of cities that have shown the interest?
Yes, we have Kuldika.
And
Yes, and other few towns as well are thinking about this idea as well.
do you have an Estonian town as well?
Yes, of course.
Which one?
Another one. Okay.
It seems like a very sophisticated and complex tool for modeling. So I would just like to maybe just of interest to know what's the innovative part of it. So as it seems from a person not in the area, it all seems very complicated. But what would you say is different than is already on the market?
Yes, we can compare different scenarios of social information. For example, we have already done here practical job, which is a part of Kaunas master plan. So it is very useful thing, for example, to making decisions for government as well for community and urban planners. So I think this universal approach to urban structure and to determine potential lets us to get the best results for sustainable development of town as well, protect valuable areas. So this, like I would say, the thing we know, but informational, our software and other synergies using data can help us to find the right decisions.
Okay, Evaldas, thank you very much. The time is up for you. And so if there are any further questions, of course, we are on a very tight schedule today, but if there are further questions, you can ask them in the chat and we'll afterwards forward them to Evaldas.
Okay.
Thank you very much. So the next one is community-driven photogrammetric modeling. Heiko, you're also online, as I see.
Yes, thank you. Can you hear me?
Yes, all done.
Great. So I'm focusing on the same challenge, but a little bit different aspect. So it's about creating a 3D model of the municipality, of the city, so that at least the virtual 3D model of historic buildings can be preserved, even if it wouldn't be possible to preserve the real ones. And also for the decision makers to be able to use that 3D model in planning the city. There are some solutions on the market. There is commercial software available to create 3D models specifically from laser scans, but that is a time-intensive and costly issue. So if there is enough money available, a city could basically order a 3D model, but especially small cities don't have that kind of budget. And the other part of the problem is that after 3 months, the model would be completely outdated because there are new buildings or old ones might have been torn down. So my proposed solution or idea is to create an environment, a web-based environment where citizens can upload photos of buildings, of streets, of historic monuments, and then the online system builds the 3D model from the photos. There are a lot of background steps that need to be taken. It's quite computational intensive, but one can create an automatic front end for those tools. So one could do that manually by hand, but it requires expert knowledge. So the idea is to put that into one solution that automatically drives the different tools. And then one can achieve that 3D model of the city, and that can be used in different applications, from city planning to attracting tourists, virtual museums. And since it's community driven to take the photos and upload them, I hope, or intent is also that it revives the interest of the citizens in their own city, because locals quite often take their historic heritage for granted because they just walk by and see it every day. So if you want to know what's going on in your city, you better ask the tourists in many cases. So one could, or the municipality could create some sort of sprint events, like we want today or in next weekend, we want to map this part of the city, maybe create a small festival around and encourage people to go there and discover the buildings in that area in detail. And I think that should, as a side effect, revive the interest of the citizens in their city. Maybe because of that, they fall in love with their own city again, and a couple less people move away. I also think it would attract visitors, so it could increase a little bit of the local economy, and especially in the tourism part.
1 minute to go.
Yes, I am actually closing up. Thank you. So we are looking both for piloting cities and also for researchers to join the team. So thank you for giving me the time to present the idea, and I'm happy to answer questions.
Thank you, Heiko. Do you want to maybe like specifically describe which researchers you are in the need of? In which areas?
Yes, so it would also involve artificial intelligence, so machine learning tasks, image processing, computer vision, part of building web interfaces. So for some areas, I know colleagues who could be interested, so to whom I can talk. But in general, yes, that's the areas that would be involved.
Okay, so yeah, I don't know how the process is, but as he has now proposed it, are we somehow able also to help him to link with those people in the Altec, or?
Yes, he is the Chaltec person.
I know, I see,
himself. So Heiko, you will find the ones, but if you need help, definitely you can also ask us, and we can try to help you.
Thinking that maybe we have some kind of tool for that.
All right. So I know people at Chaltec. I was just thinking maybe someone in the audience is who I was not thinking of might be interested to join. So
yeah, exactly.
Okay, any further questions? If no, then thank you very much.
Thank you again.
Let's continue with community inclusive urban transformation. Simona.
You know, okay, it will be you, Victoria.
Okay.
Instead of Simona.
Yes, I changed. No, I did.
Is this your screen? Or?
Yes, it's my screen. Yes. It's my screen already being shared. I just need to open the presentation. So, okay, you see it now. Yes, so we decided to tackle the challenge about the community inclusive urban transformation to empower communities to plan their city for growth. And it's not a secret that in many cities, for example, we have Tallinn, we have Helsinki, we have also Riga, we have brownfield areas, which are not developed at the moment, but which are subjected to further development. So we have a huge area with multiple hectares, which is not really connected to the other city, and where you can build quite a lot, and which is located usually in the city center or in some central parts. And of course, if you develop those areas further, new functions are coming in, and new traffic comes in, a lot of things. So the question is how to plan those areas so that the community will benefit, but also these areas don't vegetate on the infrastructure of the nearby neighborhoods, which is often the case, but somehow these areas provide added value to the surrounding neighborhoods. And if the city invests something in those areas, what would be the conditions so that if the developers develop there something and sell it off, that the city also benefits from those developments. And this is our solution. It's this kind of tool for making analysis of the available data and modeling different scenarios to meet the community established OKRs, and also to analyze what's the impact of newly building on the transportation network. Oh, I already forgot what I put in the presentation. The solutions which are currently available, it's different solutions like GIS, BIM, CAD, Power BI, Excel tables, and they are all scattered, and they provide merely like silos of data. And this data is not integrated, so you cannot do actually decisions. And what we propose, it's the tool which where everything is all in one. It's our own custom platform, and for that we partner also with the industry platform partner who provides this solution where you can integrate everything at once. So you will be able to plan the land, run different scenarios, evaluate the impact of your scenarios on the surrounding neighborhoods, evaluate what would be the impact of the traffic, compute what kind of benefits the city would get, and what would be the conditions under which the city receives the payback. And it's not only Estonian and European cities are interested in that, since it's very much for market-driven urban transformation. The cities worldwide, especially in New Zealand or in US, could be also interested in that. And those cities are, by the way, very good clients. So what we're looking for, currently we have a software developers on board, but we would like also to invite traffic engineers or everybody who does the traffic simulation to join our team and look for the solutions. How can you integrate land use planning with traffic simulations? And of course, if we have some other urban analysts, like those who are doing some CO2 analysis or some other analysis, we can also invite those specialists on board as research partners. That's the end.
Thank you, Victoria. Any questions?
I think everybody's sleepy, but maybe there are questions. So the presentation was still good, you know.
Yeah.
Next time I will make it more vague so that you have more questions.
If I would ask it about how different, actually, how much it adds actually to current, let's say, 3D models.
I can tell you one thing which comes from real life planning. Each time when you're planning new development or developing a detailed plan, you need, and especially if you're planning to build a lot of offices or housing, each time you have to do the traffic impact as well. And what happens in reality? In reality, detailed plans are outsourced to private companies, and this private company pays to traffic engineers to evaluate their plan and the impact of it on the traffic network. Of course, then you cannot say that the impact is going to be negative, because you have to provide the client some positive feedback. And what we witness that after this large development in the city, there is more traffic congestion, and all the surrounding streets are polluted with new cars. And that's a huge problem. So we think that this should be a city-level tool where inside which you can analyze different urban plans and build different scenarios so that you would have objective information, not only nice visualizations and statements from developers how good their plan is going to be. And of course, you need to analyze what kind of functions you need to plan within the new development. Because very often these new developments, they suck out the functions from the surrounding areas and they maximize the flats or the office space, and they don't provide anything to the surrounding neighborhood. And we would like to avoid that in the city.
Thank you. Just one question. Are you missing any researchers?
Yes, we are missing, okay, we are not missing, we already have in mind who we are going to invite, but if any traffic person who is doing traffic simulations would like to join, please write us. We already have some researchers in mind, but if it's from your side, we will be really glad. Phil, you had a question.
Yeah, you are probably very aware of the challenges of the existing data, the lack of data and the interoperability challenges. Do you already have a solution in your mind to overcome the interoperability challenges?
Yes, that's why we coupled up with an industry partner. We are using different techniques to get the data in diverse formats and integrate them together. We are also using AI for data mining. The setup within one city of this system should be approximately less than 1 month. So approximately 3 weeks. So it's possible.
Thank you. Thank you, Victoria.
Slides
Yes.
off, otherwise we can put the new ones on.
So the next presenter and next topic is digital twins-based asset modeling for demand-side recommendation services. And also on site. I'll be a doon, I think I hope I spell you correct.
Yeah, very right.
Is it correct or
Yeah,
no?
yeah, right.
Thank you.
Okay. Go ahead.
Just gets the clicker.
Okay.
Okay, thank you. Yeah, so our ideas based on data twin asset modeling for demand side recommendation services using AI for smart energy solution. And so what's the problem? The problem is based on the staggering amount of energy consumption that's attributed to a building. It's about 33%. And to solve this problem, we can intelligently engage end consumers, which means residents in local government or cities, to help optimize this problem or solve this type of problems. And what solution did we bring to the table that's different from what is existing? So we are looking at real-time demand response solution that allows for urban energy management, urban energy managers to view what is the lapses in their plans. And what we do is that we are able to model individual electricity assets from the local government or city, and we're able to give a real-time and predictive analytics of these assets, their behavior in the future and in real time, using the minimum or the lowest cost possible. So basically, you won't have to invest in sensor technology, and also we give you advanced user interface opportunity to interact with the systems. So what does this imply? It means we give you like a kind of a VR environment where you can have a kind of interactive visualization of what individual devices is doing, what is the associated energy consumption and wastage, or what is the CO2 production they're doing. And also you can engage this individual asset in the local government or city using a chatbot technology to have a one-on-one interaction with this asset and know what is lacking or how to improve their performance. And this is our testbed environment that we developed. We have a kind of scenario where you can interact with different installations within a city or a local government environment, the public or private installation that's associated with energy consumption or CO2 emission potential. and then you can see what their performance is, and then you can see like a recommendation system that tells you what is their status, what is the most probable, okay, it's not very clear here, but it's scored, and then you can see what is the most probable problem, and it gives you in a text format what the problem is, and you can see the model, this digital twin model that comprise of the physics and the data that is collected over time. And also here you can see we developed a chatbot interface that allows you to interact with these assets one-on-one, and then you can also optimize your understanding of what is going on with the system. So this are kind of wireframe mock-up of the end product that we are looking to develop. We actually have developed some of this, but we still need to kind of refine and test what we have. So yeah, this is the market feasibility. So if we implement this, because it's a very scalable solution, which means individual households and businesses can also adopt this model. And we are looking at in 2025 about 500,000 euro revenue potential. And this our competition. We already have some people doing things like this in Estonia, but like I said, the scalability potential, we are proposing something more scalable, both vertically and horizontally, and also investment costs for adoption of this technology is very low. So we have an edge in this area. Basically, this is a team. We are open to different cities that want to partner with us. Right now, we have a very lean team. We want to grow bigger, so we want to partner with other potential experts in digital twins and 3D modeling and AI, and also with cities that see potential in what we are doing. Thank you.
Thank you.
Okay.
I have one question, Abel. So if you said that on one slide you had this real-time, less sensors, so how do you manage that? Because usually to have real time, you have to have some more sensors.
Oh, well, in our case, we are very aware. You get very fine data when you install sensor everywhere, but it's not very realistic. If you are looking at, we are looking at going to net zero energy, net zero by maybe 2030, 2035. The investment cost is very huge. So we have to think outside the box. We are using data, smart metadata, and we are using smart algorithms to kind of identify what is going on under the station. So basically, it's much on algorithm heavy, AI and physics algorithm, physics engine heavy than smart sensor heavy. So we can talk more about it.
Because there are limits what smart meters can do.
There are limits, but we've been researching this for like 5 years, so we understand the problem, we understand the possibilities, and actually we see potential in it.
Okay, thank you. Any further questions from the audience, from the chat?
No.
Chat, no?
No.
Okay, thank you very much. Thank you. And the last from the first city planning group is the Smart City Roadmap.
Now, Fritz seems to be victorious, so they have made some changes.
Hi again. So, yeah, I will present our fourth idea. Smart City Roadmap. So what is the problem? Is that there are actually a lot of smart city solutions tried out all over the world. And the results from those solutions can be anticipated. There can be some positive feedback, some negative feedback. So like really easy one is that to understand the example is when they wanted to implement inverter heat machinery for wastewater. So the wastewater that goes out usually from the apartment building is warm. So you put the inverter there, you get the warmth, and you can heat up the house. it's a really good idea, but at the other end is the water treatment plant. And water treatment plant requires warm water. So if you take the heat out from that, you're causing problems for the next link in this chain. So it's actually, we can implement, we can figure out different smart city solutions, but the results can be sometimes different. So what we want to do is to analyze and put together, you put the next slide, put together all those, like the 100 best city experiences, how they use the smart city solutions. What are the results? Are those results what they expected to be? What is their experience? And from there, we can develop some roadmap for your city. So if you have the idea that, okay, I want to get there, what kind of solutions I have to implement to get to that point, and what it brings on? Because maybe, you know, there's a side road that, okay, I'm implementing this idea, but then I have to deal with that. So it's experience-based web sharing platform that analyzes the existing experience and provides ideas, solutions for the ideas that cities have or the problems that cities have. Yeah, and here's the call out. If you want to join us or you're expert, this idea seems promising, then you're free to join us and share the ideas, and maybe we can work something out together. Yeah.
Thank you.
Thank you.
What is the updating time? Because things change, solutions change, everything changes. So how quickly is it updated? Does it have some kind of automatic updating mechanism built into the platform? Or have you thought about this?
Well, I guess if we write those questions in chat, our mastermind behind this idea can give this more explanation about that, but probably it would be good if it can evolve during the time. So I took that idea from that city from South America and implemented here in Estonia. What was, you know, the results here and how those results are comparable over there and why there are some differences. So this is also, it can help the next one. Yeah.
I can also, I don't know, have you already mapped the, let's say, those 100 cities? What are the, I don't know, top 10 who have already implemented something and really started to talk with them? Because most of them are still kind of starting.
We haven't done this so, but we know whom to ask.
Okay. Okay.
We already have the person that we want to seduce to join our team.
Okay.
Thank you. Thank you. I'm going to hand it over to Einari.
Yeah, I like the energy topics. Okay, but without any further ado, I will just give the word to Jaanus Kaukerand and talking about building gas power plants.
Can I share the slides in Zoom?
Yeah.
Sure.
Second. Screen. Good evening. Our idea is to use buildings as power plants. And my name is Jaanus Kaukerand. I'm from a laboratory of Photogrammetric technologies. And co-authors, we have it's difficult to see Martin Hartel and Andrei Pidov. Martin is from nearly zero energy buildings research group, and Andrei is from power electronics research group. So Okay. So this challenge supports clean electricity challenge, and we are proposing a solution that will enable buildings to indirectly store electrical energy, making them power sources for virtual power plants required for balancing the power grid with renewable generation. And the solution will build on top of the DigiAudit solution developed with a Finest Center financing, and it will collect data from buildings on their operation, and thereby enabling the planning and implementation of smart controls of the building. So one side comment is that the DigiAudit solution is being already taken into use by Talte, Port of Tallinn, Estonian Real Estate Agency, and others. And the goals of the project are twofold. First, create tools for estimating the theoretical and usable energy storage capability of public buildings and other buildings, industrial buildings. And secondly, to implement in real buildings the concept of indirect electric energy storage. The problem of this challenge is twofold. On one side, the power production might be in balance, or power demand might be very high. And on the other side, electricity costs might be too high for either municipalities or businesses. So to solve this problem, we intend to use buildings as power plants. As you know, buildings have, first of all, this our idea is based on DigiAudit. From DigiAudit, we know already how to conduct the building performance audit. And by audit, we mean energy performance analysis, indoor climate analysis, and we already have experience on data collection and implementing new sensors where necessary. So as you know, buildings contain large electricity consumers, and heating systems, ventilation systems, cooling systems. And we intend to use buildings as power sources by using the building's inertia. We intend to design or implement AI-based methods to build model building energy inertia, and to use AI tools to estimate building energy storage capacity. And for the controlling the electrical systems, we intend to use smart algorithms for optimal control. And by doing this, we intend to also prioritize buildings' users' well-being. As you know, buildings, there is concerns of thermal comfort that must be not compromised, and the indoor climate must not be compromised. So the main steps of the project would be, firstly, monitoring the building electrical systems by, in most cases, utilizing monitoring capabilities of existing building automation. Secondly, developing AI-based methods and models to estimate buildings' energy inertia and energy storage capacity. Secondly, we intend to extend DigiAudit solution with control capabilities. On the last slide, I also showed the DigiAudit platform, which we intend to use as a stepping stone. And on top of DigiAudit solution, we intend to apply new AI algorithms that are interfacing to heating, cooling, and ventilation systems, electricity systems. And the last step is validation of our solution in buildings for energy savings, and also for interfacing virtual power plants. We intend to interface selected buildings with virtual power plants, and of course, the controlling of building systems, data validation. So, last slide. In this project, we see both significant research potential and also significant business potential. Potential buildings for virtual power plants will be unlocked, and communities and commonalities and businesses will get an automated estimation of their buildings, virtual power plant capability. And of course, we are looking for partners for piloting our solution, and this gives them an opportunity to save energy and receive additional revenue without any investment. And thank you.
So there is just one comment in the chat that we are planning on doing something similar here in Dunlop here. So yes, Dublin is very interested on this challenge. So just to know that Dublin is interested to come along as well.
Very good.
Right. Any other questions? Kaija.
Maybe if you could just very quickly explain to a non-expert in a way. So there are already solutions there that do virtual power plants. So, but as I understand, your solution is estimating the building's potential of being a power plant, virtual power plant.
Yes.
So those that are already providing the service, they also do some kind of potential analysis of the building. So how is your
They have an
solution
agreement.
different?
Some electricity consumers can just turn off. We intend to give a prior analysis of how much can be gained.
And also, sorry, I was part of creating that idea. I'm with Thinect, and we've been working on that for many years now. And actually, part of the solution is that typically in a building, your important parameters like temperature, air quality, they are not set at one specific value. There's a specific like bound where you want to keep these parameters. So what we know is how much we can move within these bounds and how much energy is stored within these bounds. So for example, when we move from minimum to maximum temperature, or the other way around from maximum to minimum, so how much energy we have within that region.
But isn't the fuse box doing the same?
No, sorry. So they don't know the inertia of the building. So they are just hoping that things will be okay. So, and also all the other
They rely basically on the customer itself to do that.
Yeah.
But your time is up now.
Cheers, yeah.
And we're moving forward. Thank you very much. Next one will be Noman to present the virtual power plant and grid balancing services. Yoga.
Thank you. Actually, I'm teaching for the same challenge that was proposed by the university. We are just taking a different angle for this problem. So we are proposing a virtual power plant for grid balancing services. So the problem with renewable energy integration is that we have to balance these resources. For example, if the generation is high, the frequency of the system increases. And if it's lower, then frequency decreases. And on the same side, if the load or the electrical load is higher, then the frequency of the system again decreases. And if the load is lower, then it again increases. So we have to keep this balance. And the intermittent nature of these renewable energy resources make it quite a bit tricky to maintain this load and this energy generation balance. If they are balanced, the frequency will be stable, it's around 50 Hertz. But if there is something up and down, so the balance is disturbed, the frequency can go higher and the frequency can go lower. But this also presents an opportunity. So here comes these automatic frequency restoration reserves. That kicks in after a few seconds if there is some problem in the frequency of the system. And then there is this manual frequency restoration reserves that kick in after some minutes if still there is the problem exists. So the TSOs and the DSOs, they pay very high for these kind of services. So our idea is that all these buildings which are having solar panels or some small wind turbines, or they have electric vehicles, or they have battery banks, they can all be collaborative as a virtual power plant. And in that way, we can connect with this grid distribution services, and we can provide services for grid balancing in terms of frequency. We can stabilize the frequency of the system by just turning on some loads or just taking off some loads from the grid, and similarly injecting renewable power into the grid or taking renewable power off the grid. And the TSO and DSO will pay for this kind of service. And of course, in result, there will be more renewable. There will be more capacity in the system. The city will have some kind of a small sustainable system there, and they can grow this system. This system is scalable, and all they have to do is just build some kind of a control station which is called aggregator. This aggregator will be connected with all these buildings, and in this building there will be some shiftable loads that we call, for example, a washing machine, an electric vehicle, or dishwasher that you can start, like, for example, 2 in the night or 4 in the night, so it won't disturb your daily habits. So this is the solution. And the expected outcome will be, it will be increased renewable energy, green energy. It will be a sustainable system, a totally decentralized and scalable energy system. You can add as many resources as you want. This will be also used for resilience and emergency services. For example, the grid is not there, but still this system can work on its own. And this system can provide grid balancing services. There will be lower energy cost for the city. And of course, if the user, the consumers will participate, then they will also get some monetary benefits. And it will also increase the integration of electric vehicles into the grid. So overall, it will support the green transition. Yeah, thank you very much. That's all from my side.
So any questions? So I see that there are links already between these two projects, and actually, say in addition to DigiAudit, you should maybe also speak with the microgrids project developers, as far as actually both of these, say, platforms go to very much into this same platform that microgrids project is developing. So
yeah, it's quite similar approach. Yes.
Right. They say they were actually looking for services that they can provide.
Yeah.
Complementary.
So yeah.
Do you already have the cities on board, or are you looking for further cities?
We have Voodoo on board right now, and we're
From
looking
Estonia.
for the cities. Yeah.
So foreign cities are very welcome. Of course, also if there are some more Estonian cities. About the research team, you have all you need, or is there still something missing?
We are missing on the business side. Or like the engineering side, we have like most of the people here in the Finnish Center or in the Department of Electrical Power Engineering. But the business side is missing.
So if you talk with microgrids, they might have some interesting ideas on that.
Yeah.
Yeah. All right.
Okay.
Thank you very much.
Thank you.
Thank you. So the next one will be on a code name called Visionary by Konstantin Fedoseev. And can you take it off? Oh, you don't see that.
Hello, do you hear me okay?
Yes.
Just a second. We
Yeah.
moved
Can I share my screen, please?
Yes, and we will remove this ours, and then you can. Okay.
Now you can.
Now you can share.
Yeah, hooray. Just a moment. Yeah, here it is. Do you see my screen well?
Yes,
Yeah.
go ahead.
Yeah, so hi, I'm Konstantin. I'm CEO and co-founder of at Visionary. And for almost 10 years, Alex, my partner and CTO of Visionary, and I have been working for different companies focused on sustainable architecture, on and off-grid energy storage solutions, renewables, and even electric vehicles. We created our first startup in 2016, but it failed in a year later. And then we worked for different companies and made a lot of projects, example, battery storage for subway cars and heavy electric vehicles for the largest subway system in Europe. In 2018, we started our second startup. It's a 3D printed electric bicycle, and half a year later, it failed. We decided to make our last effort and started our first startup in 2021. We called it Visionary. And with our great advisory board members who are firsthand with the electricity industry problems, we discovered the barrier for the energy transition. So we discovered that distribution power grids are facing challenges. Peak consumption is growing rapidly, causing expanding growth of charging infrastructure. Bidirectional energy flows appear on the local grid level, causing local generation with rooftop PVs. And let's not forget that grids are getting old, struggling to keep up with our modern needs for electricity, from electric vehicles to heat pumps. And without a serious infrastructure upgrade, we are looking at a future of Texas energy crisis becoming a common thing around the US, Australia, and Europe. And the traditional approach to meet new challenges, such as substations, wires, and power devices replacement, is really expensive and in most cases inefficient. The more grids we build, the more capital and operational investments are required, and the less efficient the system. That's where Visionary comes in. We've created an alternative solution that cuts off 5 times in capital and operational expenses for grid modernization and operation and modernization, reduces power grid losses up to 6 times, and helps to manage all distributed energy assets on the local level. So for cities and local communities, it brings unique opportunities such as stable and reliable energy supply, even during peak load times and blackouts. With Visionary, the implementation of local renewables and charging stations becoming faster, more efficient, and affordable. And Visionary is a breakthrough solution because it could be spread out small-scale energy storage units along the low voltage feeders, installing them as close to the energy consumers as possible. And that approach is possible with our innovations, such as great synchronization, direct management from the utility control center, and fast deployment and scaling. We provide our solution as 2 parts. It's energy storage plus cloud service, and we conducted almost more than 50 case studies with different companies around the globe. And besides decreasing operational and capital expenses, Visionary provides much more benefits for all market players, local communities, city authorities, and utility companies. And during the pilot project, we would like to gather local communities, local community authorities, utilities, and city governments to solve the energy transition challenge they faced. The problems are big enough, and we should be focused on the following goals: cutting off operational expenses of energy distribution, increasing local renewables efficiency, and enhancing reliability for local communities. Providing the fastest access for connecting the charging stations could be an additional benefit of accomplishing these goals. So yeah, feasibility study, trial installation, and receiving results, plus writing recommendations for scaling this kind of solutions are the 4 main steps we are going to make. And based on our strategic plan of development, together we can accomplish it in 1.5 years. So thank you. Please ask any questions freely.
Thank you very much. And any questions?
So I can maybe start. So who do you need from Caltech to your team in order to do the things that you showed in the previous slide during the pilot?
Actually, according to your website and list of cities, we connected with Diana Venet from Voro.
Yeah.
Yeah, and I think it's a good point to start our conversation for further pilot project together.
But what kind of researchers do you need?
We will figure it out after our conversation with Diana.
Okay. Any other questions? If not, then thank you very much.
Thank you for having me.
And we will move to the next presentation by Jan and talk about the data-driven carbon impact planning tool.
Full screen and then.
Yeah, I will make it. Okay, thank you for the opportunity. My name is Kaija, as mentioned before. Carbon impact planning tool. First of all, let me start with introducing our team. 3 departments of Caltech University are involved, and these are the representatives: Dr. Varnava, Dr. Reinsalu, and me particularly. An expert in the field of life cycle assessment, computer systems, and I'm coming from a background of computational architecture. So the challenge of carbon impact, I believe most of you agree with me that lies at the root of life cycle assessment as a solution. And how it can be evaluated, the biggest problem here is the status quo. The implementation of life cycle assessment is a big problem, especially in construction sector and urban planning, because the stages of design are ordered in this way. It goes from concept to bill of materials, and at the end, life cycle assessment happens. So no use. At the end, we just know how much we are harming the environment. While the correct plan would be this work, that the life cycle assessment starts from the conceptual stage. If I want to build a project, I know how wide the project should be, what would be the implications of this project, and the decisions that architects and engineers make. So following this solution, parametric and computational approach could help in this regard. I myself managed to calculate the carbon footprint of a building up to 92% accuracy. And it is scalable to the urban phase, but we're required to divide it into different steps, because urban problems are not small problems. We need to be phase-based. So first of all, urban elements, then urban landscape, and finally the infrastructure, which is the hardest one in my idea. So the solution looks like this. It goes for, I hope you can see the top of it, yeah? Great. Yes. The urban area requires some microclimatic simulations and to gather data by those simulations to identify what kind of usage is proper for that area. Then with defining some parameters and tweaking those parameters, we can come up with some design variations for that specific area. And then the design variations would be broken down into design elements broken down into components. And then here with the components, we can assign different materials, different processes to feed them into workflows of carbon analysis, embodied carbon analysis, operational carbon analysis, and finally the end of life analysis. These data all together will give us the final carbon footprint of the design. And when I say the design, I don't mean just the building. It can be much bigger than that, much diverse. So as an instance of how the parametric environment might work, I have a very small video for you, but before that, let me say that already Vimsi municipality has been contacted and agreed to pilot this project, but we're open to all the municipalities and partners who are interested in this idea. And we want to ask preferably to contact us by December 20, so we can plan further steps sooner. So at the last step, just as an instance of what parametric definition, how parametric definition can work, this is an instance of an urban area inside Kaija. And imagine you want to occupy this area with 3 buildings. You can see that how it can be tweaked and with different parameters, which are very simple here. It can be much more complex. But for now, I just gave it some parameters that you can tweak the places, I mean, the organization of the building, then you can tweak the dimensions of the building one by one, and so on and so forth. This is the last part of it, but if there's any question, I'm ready to answer while you're watching the video.
That's cool. Any questions?
Would you like to partner with this community tool for land use planning and traffic simulation?
I was thinking about it myself when I saw your idea. It seems very appealing to me. Of course, this would be one of the greatest chances to combine all these, because the data that you gather here, it can be used on those platforms quite well. Yeah, it can synchronize very well. Yeah.
From where do you gather the data?
The simulations that happen. As you can see, I've broken down this building into, for example, the envelope elements, you see? So you can divide it, for instance, I just have the roof of the building. I can assign different materials, different processes to the roof and run it into the simulations and get the data, you know? The data comes from those simulations. Yeah, and it can be exported in any format that you want. Yeah.
Well, just on the chat, maybe you can check later. There is also interest from Elat City.
Of course, sure.
And then actually I have one question myself as well. Well, let's say, can you also take care of the scope 3 emissions?
What do you mean by scope 3? You mean beyond the life cycle?
Yeah.
It is possible. But you know, there are so many uncertainties there. So I kind of like predicted this question to come. But honestly, there are some ideas about it so far, but not fixed yet because of the uncertainties and because of different scenarios that might happen.
And of course, the practical methodologies, regulations that are missing as well.
Exactly. That would be another problem. Yes. But I say uncertainties, I mean all of them included. Yeah.
Exactly.
Yeah.
All right. Any questions? If no, then thank you very much.
Sure.
And we're moving to our last but not least presentation about the energy carbon impact data by Einari.
He's online.
Yes.
Okay. Are you there? Can you share your screen?
Yes, just a second. I'm now presenting.
Yeah.
I will do it quite quick and practical. So firstly, I'm addressing the challenge presented by Viimsi and the following cities for the energy carbon impact data for city planning, but we are focusing on energy and buildings because we have a background in energy simulations, namely solar energy simulations. And why to do that is that, as the previous presenter also showed, there are a lot of uncertainties and a lot of different like complex matrices behind assessing planning carbon impact data. And we would like to address only one point,
which is energy, and in particular in on-site solar energy footprint. And how to do this is that we have already a technology stack for evaluating it in a 3D digital twin solution. But in this innovative approach, we would like to make it so that this automatic source data is available for the local municipalities to have some basic benchmarking for large developments and the larger areas. So you have some comparison data to do, I don't know, version A, version B to version X. And I was also a bit innovated by different approaches I see here today, and I also wanted to present another idea for this smart city challenge, and this is about proactive renovation service. And here is really a big challenge that I know that Finest has already addressed, and it is addressed all over Europe, but is the effective renovation wave, and to reach the goals of 2030 of renovating a lot of buildings that are with lower energy efficiency values. And here actually I'm again practical and will only focus and concentrate on this part of this energy poverty. And by this we mean that actually here in Estonia we see a problem is in lower income municipalities, for example, or like regions of municipalities that are having lower income housing. And we know from researchers that, for example, Ida-Virumaa in Estonia is kind of left behind in using all the subsidies and government funding for renovation. So I would like to address this challenge together with this other researchers here today, that to come from remote data analysis that also has been done beforehand, but to reach to this step 3 that will help all these apartment blocks owners, building owners in a proactive way to find financing and find the necessary technical documents to carry out the renovation. And I would like to cooperate with namely the Net Zero Energy Buildings Research Group from Taltech. Thank you.
Thank you.
So any questions to Henrik? Oh, yeah.
So with the first solution where you that was related with solar energy and the carbon impact tool there. So how do you somehow consider also the efficiency level of the PV solutions or systems? Because what I've understood is that the market is very diversified and the level of efficiency of the panels is very different and the systems in general. So do you somehow take that into account in the impact tool?
Yes. So this is our strength. Actually, we are the strongest in solar energy technical side, and we have a database of different most common and most effective technology available at the moment in the central warehouses of Europe. And we also are partnering with energy companies, for example, even Eesti Energia in Estonia. So this is actually our strength, that we will have the most up-to-date values in evaluating this.
But can you also define what kind of solar panel is planned, for example, in some roofs? If let's say if it's a low quality solar panel, what would be the impact then? Can you imagine this as well?
Yes. So it will be based on research, but basically we see from 3 to 5 standardized values to use, and then this tool will be actually a comparison between them. So if the planning documents have referencing one type of panel, then this tool is exactly the solution that will give the right comments or the right recommendations how and what to do next.
Okay. Thank you. So thank you, Henrik. And I think we have come to the end of the day.